Hey, how are you? No, not at the moment. We're just doing a warm up, go over it, warm up. All right. How'd that warm up go? Yeah, look familiar? Right. So it's the same one that we did yesterday, just instead of odds, it's evens. So I'm going to kind of quickly go through it before I give you guys the next problem in the warm up set. So how do we start? Declare a function, right? Are we awake? There we go. We got odds, takes in an array. Okay, so then what was our next step? Trey?
Define function, so I would use the reduce.
Okay.
Return.
Great. Okay. So reduce takes in an optional second argument. Is this a time we'd want to use that?
Yeah.
Why? JR.
Because you want to push the results.
Okay. Sounds good. So then inside of our the meat here, what do we need? Someone I haven't heard from yet. Andre? Great. So we can check if we want odd numbers. So we can say if for an element modulo 2. So if it's an odd, what do we want to do? Okay, yeah. So we're going to say accumulator.push. Oops. Great. Great question. So Jonathan says, don't we have to have our if statement's condition equal to 1? And so if, let's pretend this is the number 7 or something, and we say 7 modulo 2, what's that going to give us back? Truthy or falsy value? Truthy. Well, the number 1?
Truthy.
Truthy, right? Number 1 is truthy. If it was 8, and we said 8 modulo 2, what would that give us? 0? Truthy or falsy?
Falsy.
Falsy. So because we have the two possible outcomes, one being truthy, one being falsy, we don't need to explicitly say like equal to 1, because this will only run if there's a truthy statement inside. Okay, and then last but not least, we got to return, right? So we're going to return our accumulator. And I think we'll be good to go here. Oops, except for my spelling. Odds. All right, so that's working. All right, so take a minute or so to work on the next one here. Hello, goodbye. Take some time. So I want you to write a function that takes in an array and returns an array where the even numbers are now hey and the odd numbers are now bye. I want you to implement it once using map and another time implementing it with reduce.
Map and reduce.
Yeah, this is just like an example of possible input and output. But the implementation, I want it to be once with map and once with reduce. No problem.
Right hand. Right hand.
Yeah. All right, so let's go over it. How do we do on this one? Yay, nay, okay. Okay, mostly yays and no thumbs. So let's take a look. So the first thing we need to do is what? Yeah, let's declare the function. So let's do ES6 this time. Const hello, goodbye. Takes in an array. Okay. Who can help me with the next part? Janelle.
Return for array dot reduce.
All right, so we're going to do reduce. Let's do reduce second. Let's do map first. Can you help me with map or not yet? Okay. Can someone else help me with map? Max?
Turn array path map.
Okay.
Sees L that arrow. If L is natural to 1, return A, else return 5.
Okay, so that's perfect. So Max is saying we're going to return, because we're going to use map, and array.map is going to return an array, or it's going to evaluate into an array, and then our hello goodbye function is going to return that array that we're given back. Map takes in a callback function. With every element in the array, it's going to call that function with that element. And so he's saying we can do this check. We can say if that element is odd, we can return 5. Else, oops, we can return k. Any questions on that? Let's try it. Any questions? Yeah, Crispina.
Still don't understand the element modulo 2, and that's false.
Great. So let's pretend like, well, we don't have to pretend, right? We got the number 1 here. So element in the first round is a number 1. And we say 1 modulo 2. And so that's going to give us back a number. So 1 modulo 2 gives us back 1. And so this is inside of our if statement is only going to run if there's a truthy value inside of there. So since 1 is a truthy value, we're going to return by. Then map will call with the next element. We'll have the number 2. And we'll say, hey, 2 modulo 2. That's going to give us back 0. Right? And so then it's going to say, so if 0. And so 0 is a falsy statement. And so this won't run, and we'll hit our else statement. Does that make sense? Or not yet? Which part? Let's see if we can dissect it. So we've got a list of falsy values here. Falsy values in JavaScript. See if we can get them. All right, what are the falsy values in JavaScript? Like, throw up a hand. Trey.
0.
Okay, 1 is 0. What else do we have? Right, undefined, right? Undefined. Jenya? Yeah, NaN. Jonathan? No? Okay. Janelle? Empty string. Okay, anything? JR? False. Any other ones? Yeah, not that we know of, right? That seems pretty good. That's all the ones I know about. It's out of my head too. So an if statement is only going to run if this condition evaluates to something truthy or falsy. So if after this evaluates to one of these, it's not going to run. Otherwise, it will. No? Okay. So, okay, so if we have our element, so let's say, okay, let's go like this. So if I said equal to 1, and I pass in the number 5, right? We would have 5 modulo 2. That gives us what? 1, right? Okay, and so we say this is 1 equal to 1, and that would be true. And so is true a truthy or falsy value? Truthy. So we would run in our if statement. Sorry? Oh, okay. But all we really need is, we don't have to end up with true or false. If I said like, just if I put a random string, is this a truthy or falsy value?
Truthy.
Right, so this is a truthy value. So every time this block would run, we would get by. So all we'll get now is bye, 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 bye. Because this evaluates to something that's truthy. And so it's saying, hey, if this is truthy inside of here, we're going to run this block of code. So we're taking advantage of the fact that 0 is a falsy value and 1 is a truthy value. And if we use that if we know that and we can accept that, we can say element modulo 2. So then if the number is odd, we'll end up with a 1, which will be truthy. Otherwise, we'll end up with a 0, which will be falsy. All right, so we could also have written this as a ternary, right? And let's see what that would have looked like. So instead of writing this block of code here, we could decide that we're going to return, and we say element modulo 2, and then we could say by A. And with that, we could remove all of that code. Questions on the ternary? Yeah, Leo.
So the integrals we could return while I can return assign the value while I to
Can we? What do you mean?
for example, the line 440 is written by computer assigned by to EL equal to
1. We could, but we still would need to then return the element.
Yeah, finally, outside of if our state.
Sure, let's try it. So what Leo's saying is we could reassign the value of L for stuff. And then down here we could return L. Still works, but it's just more code. Yeah. That's okay to do that though. Andre.
Ternary operator only works two conditions, right? You can't enter for.
Yep. For those of you who can't hear, he said the ternary operation only works with two conditions, like if else. And yep, that's right. So we can't use like else if and all that. All right, so using this as kind of our roadmap here, as well as our previous, reduce here. Let's write one with reduce. I'm going to comment down all of this. Oops. Yeah, that should work. Okay. So, right, just like the other one, we're going to define that function. So we're going to say const. Oops. Hello, goodbye. If I can type, my hands are cold. And it's going to take in an array. And then what? What's going on the inside here? Takia? Yeah, but well, first we gotta call reduce. Right. All right, so gotta say our reduce. So reduce takes in what two arguments? Okay, so one of the arguments is a callback function, and that callback function takes in an accumulator and current element, for sure. And then the other argument that reduce takes in, yeah, so an initial value, which in this case would be an empty array. Right. Do we understand how we're at this point? Yeah, Jonathan. Good catch. We'll definitely want a return statement up there. Okay, so what can we do here? Yeah, okay, we can do the conditional, right? And so the condition is the same as up here, right? We can totally use this condition. I'm going to grab the ternary one because it's shorter. And we can say, this would be kernel. And we can say accumulator dot push. We can just push whatever one works for that. Does that make sense? Cool. And then we got to return that accumulator so with the next iteration, we still have an accumulator. So we can just return accumulator. We'll give it a run. All right, it still works. Questions on this one? Yeah, Eric. Do it the other way? Sure. Okay, so if we comment that out, we can do our regular condition. So we'll say if kernel modulo 2. Thank you, Eric. We're going to do accumulator.push kernel else. Oops. Oh, actually, it's by, right? Yep. Both totally acceptable answers. All right, do we want one more? All right, let's do it. Okay, so write a function that takes in an array and a target and returns whether or not that target is in the array, and we'll go and do it using reduce. Mm-hmm. Okay. Oh. That's awesome. You would do an average. But if you want to get creative, you join it. I'm all for it. They put change. But it's not. You make figure something right now.
And that's what I asked you for. Yeah.
Yeah.
And just like sort of. It's just like
Don't like it. It's two mixed in one.
you're not like this extra thing.
Yeah. Oh, we can sort those groups.
Oh. Just kind of
Nice.
yeah.
Yeah. Yeah.
Really? Stairs.
All right, clap your hands if you can hear my voice. Clap your hands twice if you can hear my voice. Awesome. How'd this one go? Yay, nay, okay. Yeah, this one seemed a lot harder, right? But it was pretty much the same level of difficulty. I think we just got a little stuck on this idea of having an array as initial value, or needing to return true or false with each one. So let's talk about it and see if we can't piece it together a little bit more. So we'd start with our function. So we'll say const include, and this took in an array and a target. We said we're going to use reduce, right? So, and we're going to probably, since we're using reduce, we're going to just return at the moment, like whatever we're going to get from reduce. So we say return array.reduce. Reduce takes in two arguments. What are those arguments? A callback and an initial value, right? And so that callback takes in two arguments, which are, this is the one we keep saying, yeah, accumulator and current element. Awesome. Thank you. Okay, so for this one, what makes sense to put as an initial value? Trey?
Well, I did. I put a target in at the target as
Okay, so that's definitely like one option, right? We could possibly put target in, but we want to keep checking with target against something. So what do we want back from reduce? What kind of data type do we want back? A Boolean. All right, so let's start with that because a lot of the time here, the initial value that you start with is the same data type as what you're going to want back at the end. So if we wanted to check if something exists within the array, what's a good Boolean to start with? Yeah, I would say false because we don't know if there's anything in there. We shouldn't have to turn it to false because we only want to turn it to true one time if that's in there. It's the same as when we did that for loop, right? We always started with like a false, and so because we would have this assumption that it's not in there until it is, because there's going to be more elements that are not the element we're looking for probably than the element that we are looking for. So let's see, let's try it out. So if we say false, then we got to just do what? What do we need to check? What do we say? Who's talking? Who's talking? Jenya, go ahead. Yeah, that sounds great. So if we say if current element is equal to target, what do we want to do in that situation? Yeah, so we want to reassign the value of our accumulator to true. Do we want an else statement? No, right? Because we don't want to flip it back. So then we still need to return something from this callback. Yeah, perfect. Return ACC. So now it should work. We'll say include. We'll have 1, 2. Let's pass in something that's not in our array. False looks good. Pass in something that is in the array. True looks good. Questions on this? Yeah, Trey.
So when I pass in target as my second argument, I used the include method in my if statement, and it came out saying, give me true or false.
Okay, so if you're using includes, that's an iterative method that is essentially the problem we're trying to write. We're trying to write without using include, because includes otherwise we could just write return array dot includes target. And I should look at specific. Yeah, so you are hitting your if statement every single time if it includes it, because you're not using the reduce at all. You're essentially just saying if it's in there, return true. So every single time you're returning true.
So even if I took out the reduce, it's still. That's the most intuitive way to do it.
For this one? Yeah. Yeah. And well, I mean, the most intuitive way is like kind of what Trey's saying is we've got that built-in method, right? If we wanted to, we could have just done that includes. But using reduce, yeah, this is the way you would want to do it.
You don't need to set you can do it without setting the.
How?
I mean, you're iterating through X, 1, 2, 5. You care about that. I'll make that correct. So, that's a reason I'm doing it.
Mm-hmm. Yeah, this is the only way I think that we can do this. There might be another one, but we'd be fighting. But we'd be fighting a way that's going to be more helpful in the long run. Any other questions on this one? Yeah, Neelie.
It's not as active like or it's not on. That I'm trying to think like 9 years it starts with us false. And then the first time it goes to 30, it's also false. So those, and then the next time it's false, and then the third time it's true. So it's an or statement instead of or. And, this is an logic kind of thing. So it has one true exists.
Yeah, so Neelie's saying it's kind of like this or statement. I mean, if that's a way that like helps you think about it, I think that's awesome. I kind of I personally I like to think of it just as a variable that I'm adjusting. But if it's working for you, like do it. Totally find what works for you and do it. That's awesome. Any other questions on this one? No? All right, so let's talk about, let's take a 5-minute break, but during that break, I want you to think about ways that you would sort an array without using the built-in sort method, like ways that you could possibly sort it if you had to write your own. Okay? All right, be back at 11:10 with some ideas on how to sort an array. David, does that make sense?
Yeah, I just thought
That's how we used to do it.
right. That's
We can't return out. It's just been like produced the only time we finish is to return that slide. That's right.
Maybe words like that.
You have a
Yeah, I mean that's. Oh yeah. We reassign on walls.
Yeah.
we keep flipping checking.
So then we can know from that.
Yeah, I think it's weird.
It's not in there now.
be able to like find it so it gets it. Well, that's it. That's the last time.
I seriously, I was walking on those like little gravel stones, those like cobblestones, and rain came, so like the wind came, and I started to the side. Yeah, and there was like someone passing down the keys, someone was down. So I'm like, I was like, get it together.
Otherwise, I might fall again.
No, she was pretty much just fighting the wind, so we were just tumbling on each other. If you look out the window, it's just not ridiculous, like trying to like, it's not good. Johnny. Oh.
Yeah, if you were to look at something in an array, you would use it.
Yeah, it's really good.
Nice, that's cool. But they tell you.
When I get far along, I don't know how far you are.
I'm only at like up to 6 or 7.
All right, clap your hands if you can hear my voice. Clap your hands 2 times if you can hear my voice. Clap your hands 3 times if you can hear my voice. All right, awesome. What did we get? Different ways of sorting. What did we think of? Yeah, Johnny.
Slicing.
Tell me how. Tell me like the process of sorting there. Hey, we're back from break. Let's go. Yeah, but like, what kind of like walk me through that?
And then slice one, and then slice one to the end of the length.
Okay.
And I found the cursive part, but that's the big picture.
Oh.
So every time it bubbles down, it goes back up, slicing it, and pushing it. Great.
Okay. When do things get moved?
So things get moved.
Yeah. Shuffled. Okay, fair. Trey?
I'll compare each element to
Okay.
and if it's smaller or larger than however you want to put it, you keep it there or place large. And then I'll use up and then shift.
Maybe. Okay. So what Trey was describing up until the pop shift, he's actually describing a way that is a sorting algorithm called bubble sort, which is where you compare every element of the array with every element of the array. So you would look at 3 and 5, and you would say, okay, 5 is bigger. Then you would go 5 and 4. So these would switch places, and this would become 5, and this would become 4. Then you would say 5 and 9, and you'd say, okay, this one's bigger. So then you would go 9 and 7, and you would say, all right, 7 is smaller than 9, 9 and 1, and you would go 1 here, 9 here. Then you would start again. You would keep doing it until you haven't done any switches. That's called bubble sort. We're going to write one. All right, but I want to hear other people's ideas first, but that's what we're going to write first. So, nice one. Yeah, Davey?
Why not just sort it the other way?
What do you mean, why not just sort it the other way?
Yeah, we sort. And then what Johnny was saying, use through it. Instead of taking the first one, maybe every dollar minus 2, that's the last one. And then that's what we sort it.
So, yeah, I mean, so tell me what you mean by, like, sort it the other way. Like, this is the goal to eventually sort this into one.
Smallest to the largest.
Yeah.
It's a regular.
Yeah, but how?
How?
Like, how do you write? We're not using the word sort in the code. How do you sort an array? Right? Because sort is a method that we have available to us, and somebody else wrote that, right? That is doing something, right? It's sorting this array. We don't know how to do that yet. But how is that working? How would we write our own? That's the question. Yeah, Tyson.
Can you like create like a blank array, and then like you would you consistently you would correctly find lowest number, and you consistently unshift it.
Okay.
So no, you would just like one or the other way.
So you're like saying that you could make, I think what you're kind of describing is you would have like an output array here, and you would loop through this until you get 1, and then you would remove the 1, put the 1 in here,
Yeah.
and then go through this again, and you get your 3, and you would remove the 3, oops, and push it into here. Yeah, that's possible. That could work. Neeleen?
Somebody used to have the largest number, and then the second largest, and then it was trying to get the largest. If we do something like that, we then put it. And as if we are signing, just something like what.
Well, that's pretty interesting, yeah. So you would have to generate variables somehow, right? So, and else if statements and stuff. That's an interesting idea. So she's saying, like, when we did like find the second largest element in the array, right? In doing so, we found the largest and the second largest. And if we wanted the third largest, we would have all of those variables. And she's saying we could figure out a way to like generate enough variables for every element in the array, and to use a ton of conditional statements. It's pretty interesting. Pretty interesting, yeah. Renat? Okay, cool. So that's a very similar strategy to Tyson, right? You're saying like just different implementation. Yours is using reduce to find the smallest, and then you're taking that out and sticking it in to another array. It's cool. Did we think of any other ones? All right, so let's start with trays, because that's a pretty famous sort, and it's called bubble sort. And I'm gonna let's kind of roadmap it together, and then we'll give you some time to try to write it, and then we'll go over it together. So if we had to think about it, we're going to be comparing the two adjacent numbers every single time, right? And whichever number is, if the number before is bigger than the number after, we're going to switch positions. All right, so we're going to have some sort of variable that we can keep track of, while not sorted, let's pretend. So while it's not sorted, what do we want to do? We want to iterate through it. So we'd have some sort of for loop through the array. Right, and then we got to check. So I'm just going to write in English here, but so if array at our I is greater than array at our I plus 1, we want to switch positions and not sorted. Set not sorted to false. And then here we want to return our array. Okay, so questions on the game plan? Yeah, Mateo.
Just confirm, is that pseudocode? That's not sort of
Yeah, so this is just a pseudocode, right? I haven't actually written the code for us yet. I've taken away a lot of the logical steps that we got to come up with, and kind of pseudocode it. And your task for the next 15 minutes will be to interpret it and see if you can get a working bubble sort. So just to rephrase, right, we're going to write a function. It's going to take in an array, and then we're going to keep track of some kind of sorted variable probably. And we'll say hey, while it's not sorted, we want to run this whole loop through it. Right? Can anybody tell what the time complexity is just off the top of their head right here? It's n squared, right? Because for every element, we're going to go through it every time. So we're going to start from here, and we're going to say 3 and 4 bigger. Nope. 4 and 5 bigger. No. Oh, but this is already. Why is it? Do I not have a sorted array right now? Oh, this is just. I'd say, all right, 3 and 10 bigger. No. 10 and 5. Okay, those need to swap. So we'd say 5 and 10. 10 and 7. Swap. 10 and 9. What do we do? Swap. Yeah. 10 and 1. Swap. Then we start again. 3 and 5, they're fine. 5 and 7's fine. 7, 9's fine. 9 and 1. Time to swap. 9 and 10, that's fine. 3 and 5, fine. 5 and 7, fine. 7, 1. Gotta swap. 3 and 5, 5 and 1. Gotta swap. And this will keep going. 5 and 7, fine. 7, 9, fine. 9 and 10, fine. Right? Get the 10.
break out of function. Breach type of thing.
How do we break out? Is it,
I mean, 'cause I know instead of having to go breach.
well, we are going to break out once we get through a whole loop without switching positions.
But I'm saying, like, it seems like the way the one is getting run, not because we're iterating.
Right, this is not the most efficient sorting algorithm out there. And then we would start again, we have 3 and 1. 3 and 5, 5 and 7, 7, 9, 9 and 10. And then we would have that this is sorted. And we would break out and return our array. All right, give it a shot. I know it's tricky, but it's a good practice. Did you have a question? Really try not to just look it up. All right, there's no challenge to that. So I've written down all the steps. Really try to stick to this game plan. If you veer off, it's going to be a lot harder. You're going to need a while loop. You're going to need a for loop. This switch is not really a switch statement. This is a swapping of position.
We just have 2 for loops instead of 1.
I mean, you technically can. Typically see with a while. I don't think that's it's not like a number iteration, right?
I mean, I kind of looked at it like that. First for loop is going to each element, or represents each element, and the next for loop represents that element going to each element. Like this.
Yeah, it might take a while to see one is going to
While this is while this is for it.
what we use for Okay, so even more detailed roadmap there.
Well, no, right.
So we're at 9 plus 1, 3 times. In 4.
All of that. These are there. That's fine. No. No, erase and do it. Mouse to there.
Yeah.
mile per hour, right? On there. Does that make sense?
I'll go back to that.
Question. It's a math question.
See this? So it was one way I must want to do that. And I was one where I could do and this way, which is using object structure, sort of. All right, let's go over this. How we do? Yay, nay? Any yays? Anyone get it? Yeah, a little bit, couple. Okay. Yeah, it's tricky to write our first one. Let's do it though. Let's do it together. Let's go through with our roadmap here. So first thing, let's declare a function called bubble sort. All right, I think we know how to do that. Function bubble sort takes in a array. Cool. Let's look back at what we did. So this is the kind of roadmaps and stuff I talk about when I say, like, during your whiteboarding, make a roadmap. This is what I'm talking about. Like, if you follow this to the T, and like, especially if you wrote these yourself, because then you know exactly what you need to do with each one, right? It's a little harder because you're interpreting somebody else's roadmap. Although, still, if you take this very literally, you'll be in very good shape. But if you wrote your own roadmap that was this clear for yourself, you should be able to just bang out that function. So this is what the goal is when you whiteboard. So anyway, so we say make a not sorted variable set to true. Okay, let not sorted set to true. Okay, what was next on here? It says while not sorted. All right, while not sorted. And then I said, change not sorted variable to false. So why? Can anybody tell me why I might be doing that? Yeah, Johnny. Yeah, to break out the while loop. Eventually, this thing's going to be sorted, and I don't want it to keep going. So we'll move to our next one. Oh, we got this for loop that's going to iterate through the array. All right, for let I equals 0, I is less than array, r.length, I plus plus. What's it say for me to do? It says if array 1 is greater than array 2, I want to swap positions. Okay, let's keep going. So if array at I greater than array at I plus 1. Oops, what did I do? Got to swap positions, right? So there's a few ways we could do that. One really cool way I saw people do was they made a temporary variable. That's fine. We could say let temp equal array at I plus 1. And then they said array at I plus 1 equal to array at I. And they said array at I equal to temp. Right? Does that make sense how we got through there? All right, that was one way. The other way is this like sexy way up here that uses object destructuring to our advantage. Just another way we could do it. This is like very hip way of doing it, but this is the older way. I can't really explain like what's going on under the hood, but it's assigning this to this and this to this, but it works inside of arrays and objects, things like that. It's an like 6 plus thing. Yeah, Mateo.
Does it work on property?
What do you mean?
Like this dog, color, and then half dog color.
I'm not sure. I don't see why not. I think it might. It'd be something to try. Couldn't bang out that example off the top of my head. Haven't changed cats and dogs colors in a while. Johnny. Well, it just does the same. I mean, there won't. What do you want me to console log?
Higher line 8.
Sure, we could try that. We'll do that after. So we could have done that. Let's keep going. Let's keep following our roadmap because we could. I think we could have all figured this one out, right? This is pretty not too off the wall here. It's just creating a temporary variable to keep track of a previous value. This is kind of similar to the way we had to update the order of our second largest element in those methods. We didn't have to keep the temp, but we had to like care about the order. Okay, and then it says set not sorted to true. Okay, so we've done a swap. So if we've done a swap, that means we weren't able to get all the way through it without making a swap. Therefore, we don't know if it's been sorted yet. So we'll say not sorted to true. And it says, oh, return array. So we must be done. This function belongs to here. And we will say, whoops, am I outside the while loop here? Sometimes I get mixed up. Yeah, right? Should be. Return array. Wait, we have all this other. Yeah, okay. Return. Okay, so let's try it out. Okay, bubble sort. 3, 4, 6, 9, 1. 1, 3, 4, 6, 9. Looks good, it works. Right, so we just followed that roadmap. If we were really careful following the roadmap, we hardly had to do like any problem solving there.
Sorry, can you talk about line 100?
Line 100. This is setting it, okay, great. That's a great question. So line 100 is we're setting not sorted to true, right? Because the while loop is going to keep going as long as our array isn't sorted. And here is where we're breaking it. Every time we start the while loop, we're saying, hey, if we never update the array at all, by the time we get to the next loop, then we can assume the array has been sorted. We can accept that as like we agree that we don't have to go loop through it again because there's been no changes. Here is where we say, all right, well, we've made a change. So even if we swap one number, we don't know, like that changes something in the array. We don't know what number got swapped. So we have to do another loop to make sure everything is still honky-dory. Is that the expression? Crispina?
We're starting with not sorted as true, and we're going to probably true, right?
Mm-hmm.
And then we're setting it to false at that. Why do we have to, and I know that Johnny said to break out of the loop, that's why we're
Yes.
false, but I don't understand
What that means? Great. So Crispina's asking, like, why we have to set this out. What does it mean to, like, break out of the while loop? It just means, like, we don't want to do another loop inside. So as long as what's inside of that while loop is truthy, we will continue to run that while loop indefinitely.
So we're going true when we enter it. We're going to do the code block, and then we set it to false. Afterwards, or after we're already in it, so it's false. And then I see all the way at the bottom, it's like
Right.
What's the point of setting it to false?
So we don't always hit this. We only hit this if our if statement has happened. Right. So if we've made a swap, we don't know if our array is completely sorted. And so because of that, we got to make another loop. Otherwise, if we never hit this, we want to stop. So we set it up at the top. If we set that at the bottom, we would still hit this if statement, and then we would hit our return, like set it to false, and we'd go, oh, we're broke out, and it's not really sorted. Rock and roll. Now for Johnny's question of what's this line, let's console log it. .log. Now I highly encourage you, if you have questions like let's console log stuff like this, I highly, highly encourage you to just do it on your own. Console log it. But it does that. I don't know. It doesn't help me too much. I mean, it's not so much what this evaluates to as what it actually just does. Swap the positions. Yeah, but it might not evaluate to the way we're hoping.
Those are indexed?
I don't know. You would never use like the output of that. You would only use the effect of that. So I don't know. Okay, so we got bubble sort. Any other questions on bubble sorting? What's the time? What's the big O time here? O(n) squared. Yeah. So for every, because we're looping through it, and then we're looping through it for every single element. We're looping through it again. I mean, with the exception of like, if that. I mean, it's like worst case scenario or an average case scenario, like O(n) squared, right? As long as there's, unless it is already sorted, then I guess it would be. Then I guess it would be n, but like, then you already have a sorted array. All right. So let's think of another sorting algorithm. All right. This. Yeah. Yeah, I will. I'll share all of it at the end. So let's think of another one. So there's a really cool one that's called merge sort. This is like the most famous and popular. There's two that are really popular. It's like quick sort and merge sort. We probably won't have time to like hit quick sort today, but we can hit merge sort. Now merge sort works like this. I'm like draw it up on the board more. So pretend, okay, so merge sort is a recursive function. So it's going to call itself over and over again. And it looks something like this. So if we have, I'll just make numbers. Let's say like 3, 5, 2, 1. So the way merge sort works is it splits itself. So if this is an array, splits itself in half, and it calls itself with that half. So we get 3, 5, kind of like a divide and conquer concept, 2, 1. And so if it keeps doing this, because when is an array for sure sorted? How about that? Let me ask you that. When do we know an array is sorted?
When it has one.
When it's one element, right? One or less element. So the base case there is we're looking for array.length less than or equal to 1, right? Because then we know for sure it's sorted. Okay, so we still have this, so it's going to keep calling itself, and it says, all right, we're going to call it a 3 and a 5 and a 2 and a 1. Okay, so now these return as sorted. Now there's a second function that happens with merge sorter. That's a merge function. What a merge function does is it takes two sorted arrays. So merge two sorted arrays, and it returns one sorted array. One. So, okay, so let's think about it. So if we call merge on this, how can we merge these? How can we look at, yeah. Yeah, we could use concat, but right now, like, how do we know which one goes first? What can we do? You can compare at where? At what index? 0? Okay, so if I said, let's have this output array, and I said, okay, whichever one is at 0, smaller, we'll push it in. I said, all right, well, gets pushed in. This gets popped down. 3. We go, all right, well, this is empty now, so that's done. So once an array is empty, we can concat them all, right? Because it doesn't matter if we could do like output dot concat an empty array dot concat whatever's left. Like we don't really need to know what's left because we know for sure that it's just whatever's left over, and that's the rest of the correct order. It's already sorted. So then 5 gets in here. So now this has been sorted. All right, so now this happens over here too. And so we have our output, we're comparing at 0. And so we end up pushing in a 1. And then that becomes empty. And okay, we add them all together. So now we get a 2. Okay, so now we have this 3, 5, and this 1, 2. Okay, so if we go back up now and we merge those, well, let's go through it. So if we have 3, 5, and 1, 2, 3, 5, 1, 2. Let's do it. How do we follow our rule here? So we have output, empty. What's the first thing we look at? Luna? Sorry? Perfect. So Luna says we got to compare the first index of both of them. So we have a 3 and a 1. What do we choose? 1, right? So we're going to shift that out, push it into here. Okay? And now we have a 2 and a 3, right? Also, still at the 0th index now. And we take the 2. We go, all right, now we got the 2. Now, since one of these is empty, we no longer care. We know for sure that the rest is going to be okay because it's already sorted. This is the only one with anything left. So I'm going to concat both of these to our output. We get 3, 5. That's how merge sort works. It's kind of cool. So let's, yeah, Christina.
Please bring up the title of the sort that you were working on right now.
That one was merge.
Merge sort.
There's 2. So there's merge sort. This is in charge of breaking it down to a left side and a right side, calling itself again. And then there's merge, which is in charge of merging 2 sorted arrays. But necessary. We cannot merge non-sorted arrays. Yes.
So what if the variable array cannot be divided?
Well, that's what we have. It's less than or equal to 1. An empty array is still a sorted array.
For example, it's a smaller number of data lines, all numbers, how we display.
Yeah, that's fine. Where however we want, we get to choose how we want to set it. Mona.
What are the instances where we should be using this merge sort versus just sort?
Oh, this is theoretical. It's like computer science, like classic understanding sort is super important, like showing like a well-rounded understanding of JavaScript and how things work. Like most of those sorts under the hood that when you're using is using kind of a merge sort, although they're probably not doing recursive because of the stack overflow that could happen. It's probably like an iterative merge, which is super, a lot more confusing. So like you wouldn't, if you couldn't use a built-in sort, I guess you would use this if that was like a restriction. But like this is more of like for understanding and knowledge. It's a good question. Yeah. In a real program, if you've got to sort something, you'll probably use the built-in one. It's probably faster, even like better. Leo.
Yeah, so what was time context?
This is n log n. The fastest way you could sort. Yeah,
It would work more like this.
yeah. So we're gonna write it off, but we're gonna break it down into pieces. Okay. So the first thing I want us to write is a merge function. So we want to declare a merge function. This will take in two sorted arrays. Okay? Now, while each has a length, we will compare the first indices. Right? Does this sound familiar to kind of what we were doing over there? Right? We had two, and we were looking at the first indices while they had that length. Once we determined that that length was gone, it didn't matter. Compare the first indices, remove smaller indice, remove smaller element, and push into output array. So this will be, it doesn't let me do what I want, okay? We will have variable output, and then what else do we want to do? Return all arrays if that. Okay, so let's work on this for about 10 minutes. Follow that roadmap. Really think about like how we were doing it on the board, try to like really internalize it, right? This isn't merge sort, this is just merge, which we will use in our merge sort. That's for our merge sort, but we want to stop in the arrays less than we got sort. But this is merge. This is yeah, what we need.
But that's fine.
All of them wrote.
class. Sorry, I was thinking about literally, I was gonna push. Shit. Like. We have feedback.
All right, let's go over it. We gotta keep on going. Clap your hands if you can hear my voice. Boom, shakalaka. Let's do it. So let's follow this roadmap that we got. It says declare a merge function. All right, function merge. It takes in two sorted arrays. Array 1, array 2. Great. So now let's make a variable output. What do we want our output to be? What, an empty array? Yeah, that sounds good. So we'll say let output be an empty array. Great. So then our next thing says, while each has a length, we will compare the first indices. Okay, so sounds like kind of a loop to me. So let's go while. Takes in a condition while each one has a length. So we know that 0 is a falsy value, so we could just say array1 dot length and array2 dot length. So this way, this is only going to run while each one has some kind of length. All right, that sounds fair to me. And then it says we compare the first indices. And then we're going to remove the smaller element and push it into the array. So this sounds like an if statement, right? So we can say, all right, so if array1 at what? At 0 is less than array2 at 0. What do we want to do? Yeah, so we want to do output, dot push. What do we want to push in? Array1 at 0, but since we want to mutate that out so the array keeps getting shorter, what can we use to get that? Yeah, exactly. We could do array1 dot shift. Right, we know that this will evaluate before this. This is the way it operates. So if we've got that, we can write our else statement. So otherwise, we'll just push in array2 at shift. So we'll say output dot push array2 dot shift. Okay. Any questions so far? All right, and then it says return all arrays with concat. So eventually, we don't know, one of our arrays is going to be empty. And there's still going to be at least one number left in the other one, right? Because if I have an array of 1 and 2 and I push the smaller one in, we still have that array with 2, right? We haven't done anything with it. So, and our while loop's broken. But we don't actually know which array had that 1 or 2. So we can just concat all of them. So we can go, all right, we'll say output dot concat. Now this could be an empty array. We don't know, but we also don't care because it just won't do anything. And then we'll say dot concat. And this one, if it's just all numbers that are bigger, because we know they're sorted, then they're in the right place. Yeah, thanks. Not that I know of. But I mean, did you see that? I don't know. I'd have to check the documentation. Totally possible. I know we could use the spread operator here, right? We could also have done something like dot output dot array 1 dot array 2. Return that. That works. Yep.
Do you have any, in the previous one you did with concat, would you also return with that? Did it return?
Yeah. Oh, I meant to return. Sorry. Good catch. All right. So we could concat. We could do this. It's essentially the exact same thing. Let's try it. All right. We got to delete. We got to comment down all this. Make sure everything's cool. All right. So then we'll say merge. And it takes in 2 sorted arrays. So we'll say 6, 7, 7, 98. And we'll have one that says 1, 2, 4, 9, 65. Sure. And let's see. Okay, so that's working. Returning 1, 2, 3, 4, 6, 7, 7, 6, 9, 6. Okay, so that works fully. Okay, so we're going to use this function. Now there's going to be a mental leap here. It's super weird by the end of this, but we can do it. I know we can. So we remember that the merge sort is what we're going to write next. And that merge sort is recursive. So we're going to write a function, write a merge sort recursive function. So we know it's going to call ourselves. Oh man, we're running out of time. Great. And we want to do 2 things. We want to, it's base case, right? So the base case we decided is when is an array for sure sorted? When it's empty or one element, right? So return our array when its length is less than 2, right? And then inside of this we want to split it. So we want to find middle of the array. And then we're going to want to say take left side and take right side. And with these, we're going to want to call merge sort on them, right? Because we've got to call merge sort on each one. So we'll call merge sort on each. And eventually, it's going to return back a sorted array, right? It's going to break it down to be 2 1s. So then call merge on result of previous line. Okay, let's try to pump it out. Any questions on that? like what we're trying to do? We're going to be breaking these down into halves, left, right, until they're down to just the one. And then they're going to be merging and bubbling back up. And they're going to keep merging until we have one array that's merged. It's a tricky one. Let's do it. I'm only going to give us 10 minutes so we can like still go through it. Yep. That's so the whole merge has to have sorted arrays for the store. You guys don't have to worry about retyping everything. I'll share it on Constant. Probably have to wait 5 minutes to retype.
There was a question.
This was good.
Not sure.
Super fast. I put them on all. Even a more case scenario. That's as fast as you can. Yes. One person.
Right. I just felt like we had to like have.
Oh, merge and sort. Merge is the one that takes two sorted for a person to get out. No, okay, that makes sense. Yeah, no, that would be so weird. Yeah, yeah.
Perfect. Is line 116 supposed to be the base rate?
All right, I know a lot of us are still working on it, but we gotta go through it in order to beat lunch. All right. Let's follow the roadmap. It's a pretty good one. So let's say we got a function called merge sort. So I'll say function. Oh my God, my hand got really cold. I washed it in the bathroom. Merge sort. So it's going to take in an array, and we've got our base case. This is when we know everything is sorted, right? Boom, it's sorted. That's when an array is less than the length of 2. We can be sure that it's already sorted. So we can say if array.length length less than 2, we can return our array. Bada bing. All right? Do we need to test this, or we believe that that's happening? Okay, so then now we got to find the middle of the array, because we remember the way merge sort does it, keeps splitting it up until we get to that smaller array. So let's find that mid index. So let's say let mid index. Well, math.floor, I'm going to round down, because if it's an odd number, there's no index 2.5 or something, right? So we're going to say array.length divide by 2. Okay, cool. So it says take the left side and the right side. All right, so how can we get the left side? Maybe someone, yeah, Alex, okay.
The left side equal array.slice.
Oh yeah, okay. If we didn't want to just like mutate that though, we could use slice, right? A lot of people aren't that comfortable with splice yet, so I just want to use slice. We don't have to right now. We're gonna call, we can slice half of the array and call merge sort on that half. Here, just because we're not, a lot of us, we're not comfortable with splice yet, so I don't want to use splice. But we can say slice at 0 to the mid index. So this will give us the first half of the array. Questions on that? Goes from the 0th element all the way up to, but not including, the middle element. So with the same idea here, we can do right side. Let right side equal array.slice, and we can start at the mid index. And the second argument is optional, so if we want to just go all the way to the end, we can just leave it off. So now we've got our left side and our right side. Fair? Okay, so now we got to make these smaller, right? Because we got to get them back to the point where they're sorted. So we can say, if this is kind of where the mental jump happens. Okay, so let's, in the perfect world, right, we could kind of say like, maybe this will work instead. I'll say let sorted left. Let's see if this works. I haven't tried. Yeah? Okay, cool. So I'm going to say let sorted left equal merge sort of our left side. Okay? And then I can do it sorted right. Let sorted right equal merge sort of our right side. Okay, so now this is going to keep breaking them down all the way until there's 0. But then, so when we finally get to those individual arrays, that's when we want to merge them, because we have a merge function that we wrote that merges sorted arrays, right? So we can start with merging an array of length 1 and an array of length 1, and we merge that, and we get an array of length 2, and then we can merge that with another array of length 2. So we can write return merge of sorted left and sorted right. That's merge sort. So let's try it. I'm gonna say merge sort. I'm gonna pass in an array. I'll say 7, 3, 8, 90, 2, 1, 3. Let's see if we get it. Nope. Oh, probably because I have all these instructions. Let's try it again. Oh, yeah. Like magic. Yeah, we're not.
So the point is you're actually sorting that in when you're there, right? Other way to make sort is actually
Sorry, I'm having trouble hearing you.
I'm just trying to understand the point where you actually sorting. Is it only at when you return marriage and sort whatever you did?
Okay, cool question. So we're not more or less asking like how is this happening? Okay, so let's pretend we've got this array of. Let's just follow the call stack, yeah. Let's say we've got an array of 3, 1, 2, 4. Okay, so we don't hit our base case. We get our middle index, which is math dot. So 4 divided by 2 is 2. So I guess we end up here. Maybe we should adjust our basis. Whatever. So we get our left side is 3 and 1, right? So we have a left side. We're going to call it LS, and we're going to say it's 3 and 1. And we got a right side, and that's going to be 2 and 4. And then we call merge sort on our left side. And so we start another call here. We're dive into the call stack, and we say, does this hit our base case? No. So we're going to take 1 here, and we're going to have a left side. We're going to have a left side of 3 and a right side of 1. Right? Now we're going to call merge sort on the left side. This is just going to return this. And then we're going to call merge sort on the right side. It's also just going to return this. Then it's going to call merge on both of these. So this evaluates 2, 1, 3. So that evaluates. This gets changed. This is now 1, 3. Now we're on our right side, and it calls merge sort. It doesn't hit our base case. We get our left side, and so we go left side is 2. Right side is 4. But arrays. This does hit our base case. This evaluates to 2. This hits our base case. This evaluates to 4. We merge them. It becomes 2, 4. And, well, this was already 2, 4, but I'm changing it otherwise. And now we're back to our original call here. And they're already sorted. So now we merge these. And so we return a 1, 2, 3, 4. That's the order of operations there. Yeah, Alex.
Is there any reason you assign those function variables?
No, you could put them directly. And the reason I did it clearer for people is that
So essentially what you're doing is just trying to get every index in that array and slice it down to one element in that array, and then that way you can compare it to another one. And it's that automatically sort those in that merge sort, then it's going to take the next two, just keep doing that with every single one.
pretty much it's just going to keep breaking them down in the smaller and smaller pieces. And then once we hit the base case, it can start building them back up. Sorry,
find sorts it.
Line 130.
But the merge set it up.
It merges sorted arrays. So, but it starts, it's only sorted when it hits one element in that array. So, kind of a combination. Christina?
Is the recursive part happening 128, 129?
Yep.
Question.
Yep.
So we're about to call other functions inside of the version.
Yep. Totally. The question, that question was kind of quiet. He said, are we allowed to call other functions inside of a recursive function? Oh yeah. You can call any function anytime. I know, it's a lot to take in, right? It's pretty cool. Yeah. And log in. Always. Fast as you can go. All right, so now it's lunch. When you come back from lunch, it's going to be independent or like group, however you want to study, till about 3:30. And then people can come in and like ask me specific any questions that they have for like tomorrow and what to expect, any other clarifying questions. It's kind of optional. You don't have to be here, but you know, if someone asks me something, your knowledge is power. That's it, okay? And then it'll just be kind of like independent work for the rest of the day.
Like keep slicing it down to just each element is basically has its own array of zero index, and then the merge, called the merge, which basically ends up like doing the sort.